Hello and welcome. I'm the Giant Woodworker and I had a problem. I wanted to replace my plastic tool storage containers like these. They were just ugly. They weren't made out of wood. I had a CNC machine now, so I figured, hey, I want to make one of these. How do I do that? And then the next big question is, how do I do nice joints if I just want them to come together right away? And I did not find good enough answers online. There may be some out there, but I didn't find them. So today we're going to talk about how we can make something nice like this, build it on the CNC, and actually have it come together really, really nice. As joinery, I'm using Mortise Tenon effectively here. You can probably apply this to pretty much all other joints as well, and we will use some very simple dog bone, hole techniques on the side, but I will hopefully explain everything that you need to know now. The very first thing that you need is a plan. Without a plan, you cannot do anything here, like everything you do in woodworking. If you don't know what you're trying to make, you can't make it. Very simple. The first thing here, it really doesn't matter what size your material is, because we will change this later, and you're probably not only going to make one of these, you're probably going to make multiple of them. So a bunch of scrap wood is probably not a bad place to start to make this on. So leave that as it is. This is VCarve PRO 12.5. I believe it works on VCarve desktop as well, probably Aspire. I'm not super familiar. I'm not Mark Lindsay. I am the Giant Woodworker. So I will try to give you as much information as I can with what I have. But first, you have to figure out what you want to do. And I don't mind starting with a little rectangle over here and some text inside to help us determine that. So for my case, I want to be 3 inches. Let's start at the front. The inside diameters, or the inside measurements that I have, is 3 inches on the inside wide. So 3 wide. Let's say 6 long, and this is the distance from the wall, from the French cleat out. And then maybe 3 or so high. And again, this is all the inside measurements. We also have to understand material matters, especially for the joints. You cannot make a mortise or a tenon bigger than the material that you're going to fit into it. So in my case, I will use a 1/2 inch fiberboard is what it's called. I can get a sheet of 4x8 at Menards for 20 bucks, and I just wanted to try it out. I was like, it's so cheap. Let's make something out of this and see what happens. If it fails, not a problem. And I made a rolling cabinet out of it already. Works just fine. So I'm pretty confident that this will all be okay. But we have a 0.5 fiberboard. Fiberboard, or all the sheets, are not always the same. Mine actually, some of them were 0.51 inches. Some of them were 0.49 inches. So just make sure that you measure this with the material that you want to make. So for simplicity, we're just going to go with 0.5 inch fiberboard. Anything else? Not quite, not really. So we can just get started. Cool. These are the measurements that you really need, so let's get going with those. First, let's build the bottom of the toolbox. So the tool tray, the inside of it, that is the bottom. That is what I will call the bottom, and that's what we're going to make now. For that, honestly, it's pretty simple. All we have to do is build a rectangle, and the rectangle should have the sizes that we have over here. So what did we say earlier? We said we want to be 3 inches wide. You can decide if you want the width, the x-axis or the y-axis. In my case, I'm going to go the y-axis with 3 inches, and the x-axis is going to be my length. So this way, just 6 inches. Cool. If I say apply, this is my size. Cool, it got a little smaller, not a problem. Now, the first problem. What we want to build is the inside of the box. There's still stuff on the outside. So you have 2 options here. You can either make a square that's a little bigger than this, or you can use offsets. The problem I found if I use offsets, which are down here, is if, let's say, we know that we need 1/2 inch on all directions because our fiberboard, our material, is 1/2 inch, then we want to add that here and move that outwards. We have to make sure that we create this with sharp corners. And do I want to keep the original? I want to keep the original, so we're going to leave that. Let's throw that out here, and it looks like this. Wonderful. I actually just found this out, because if you don't click this button and you move it outwards, inwards is not a problem, but outwards is a problem because it will make this really, really round, and we don't want that. We don't want that at all. So Control Z, Click on this. Your distance is the material thickness. That is very important, and you just create that. And now you have a box. This is the inside diameter of your box, and this is the outside diameter of your box. Almost everything in woodworking is a box. Doesn't matter where you make it, and this is where we start. Cool. So with that in mind, we know what our inside diameter and our outside diameters are. Wonderful. Let's keep moving. Because of how we want to build this, we should, get the next pieces. What are the next pieces? We have the bottom. We will need a front, a back, and 2 sides. That's what we need. There's no lid on this. So I'm just going to continue with the tenons that we want to build here. And to make those work, I'm actually going to use, if it will let me, I'm actually going to use this line tool, and we're just going to extend this X or this corner out to here, space, let's see, start a new one, from there to there, space, new one, from here to here, space, new one, and then from here to here. And now you have this extended out with a 1/2 inch. This is the material that we used as the offset, which is the same as the thickness of our material that we have up here. Again, it's very important, so I'm going to repeat this over and over again, but I hope it all makes sense. So we have our thickness there. Great. We don't want all of this. We definitely don't need this. We could leave this to say, hey, this is where the back is going to go in, this is where the front is going to go in. But honestly, it's not important for this because I will just leave these things together. Or like as one piece, it doesn't have to be smooth, it doesn't have to be fancy. You can make this as fancy as you want, but this is where we're going to start. Great. Now, next things next. Where do we put the tenons? For right now, I am thinking that I want a tenon effectively where these upright bars are, stabilizers are, whatever you want to call them, somewhere in that area, which is not all the way to the back, not all the way to the front. So, where's a good place for that? I'm not sure, but we can play with this, and we have tools that will help us. I'm going to put some guidelines over here. If you don't know how to add these, you really just drag from here over, but you cannot have anything else selected while you're doing that. So we'll drag those over, and then I'll see, I know that my 1/2 inch wall is going to go in here, so I can't just go 1/2 inch in. And then I just need to go a little further than that. What is a good distance? Honestly, about 1 inch is not terrible. So how about we do 1 inch here? We're going to do the same thing on this side. So -1 inch because we're going backwards. Also new guideline. Now we have those guys right here. And then we're going to build a tenon. The tenon doesn't have to be anything complicated. All we're going to do is make something that's about this big. It's almost there. It's 1.02 inches. I don't really want that. I just want you to be 1 inch by 1/2 inch. Again, this should be the measurement of your material. Very important. So let's set this one up. That looks okay. If you zoom in, you can see that we're not quite on the guideline. We're just going to move it over, drag it a little bit. And that is our first part of the tenon. It will maybe be helpful to copy this for later. So I'm going to move this again with my left control click. Just move it all the way out here. That creates a copy of it. And now we have an extra guy. Feels good. I would like to have another extra. Left control click again. We'll just move it over here and it stays within all the same dimensions. And now we have a tenon there and a tenon there. Do you feel like this is good or do you feel like this is not good? Completely up to you. If you don't like where it is right now, you have many options to move it. The move selected object is nice because we can just say in X, move another inch that way. No, that's too much. In X, Control Z, move another 0.5 inches. How about that? 0.5. Move that much. That looks good. I like that. Okay, so we're going to do the same thing over here. Instead of positive 0.5, we're going to move negative 0.5. And you just have to figure out which direction you want to do. I highly recommend keeping this relatively symmetric. It will make your life easier for when you put things together where things are not left and right and top and bottom and all those things. They're just all in the same place. But I kind of like this. So let's go with that. I really just want to copy these to the other side. There are many ways that you can copy them. I'm just going to use this one. I'm going to drag this. I'm going to hold the Alt key. The Alt key keeps it in the dimension that we're going. So we're going down right now. If I go too far over to the right, it will start staying on the X-axis. Now it stays on the Y-axis. That's good. And then I'm going to hold left control as well to just move these down here. And I'm really just going to go plop them right there. So now we have tenons here and tenons here, but you will say there's too much stuff around it, which that is correct. So the next thing we have to do is remove some stuff that we don't want. The top line there can go. This line down here can go. These lines can go. They're usually easy. And then this line should go. That line is generally hard. I have had this problem so many times. But don't worry, that's an easy fix. Control Z. And then this is probably a tool that I end up using the most when I have to fix anything. Click on any of these and click on the square. It's easier that way. Then press N on your keyboard to go to the node mode. You can see that there are 1, 2, 3, 4 edges. This edge is the one that's in the way because it's overlaying this thing, but it's actually on top of the other edge, so it can't be removed very easy, which is annoying. But you can either right-click on this and say delete span or learn shortcuts. Highly recommend using shortcuts for this, and just press D when the little squiggle is on. That means you actually have something selected here that's hovering over it. D, remove this edge, the green dot, the starting point for this vector move down here, and that looks good. We're going to do the same thing over here. Just hover, and if you want to remove the point instead of the edge, it will do the same thing. Now, when we use our scissor tool, it should have no problem removing all of this. When you have scissors, it's not a bad idea to let them rejoin trim sections, because now when I click on this, all of it is selected. You may be able to see, it may be hard to see, but there's some black lines underneath here that I don't want. Many ways to get rid of this. The nodes are one way, but if they're not cooperating, this is the other way. You know how when you drag from right to left, you select everything that you touch, and when you select from left to right, you only select what's inside your selection. So let's make use of that. I'm going to select these two items. There are two lines here. Press delete on your keyboard, and now you only have one nice clean vector sitting right here. Beautiful. That's what we wanted. And that's the first part. That's the base. But trust me, we're not that far off at this point from doing the rest. So what else do you want to do? Well, I would like to put the sides up next, and the notes, how you want to move this around, is completely up to you, but I'm going to do the sides next. So what is our height and our width? We are 3 inches wide. Yes, that is the width of this guy. We are 6 inches long. That is the length of this guy. And then we say 3 inches high again. Is 3 inches enough, or do you need 3.5? 3 is probably fine. 3 wide, maybe a little narrow. 3.5 maybe a little better, but that's up to you. You just play it however you feel, or whatever things you want to do where you are. That should be fine. Where I would start is get a rectangle. You already know that your length is 6 inches, and then we said our height is 3 inches. Don't worry about where you end up with this thing. It doesn't matter. The main thing is that you get the exact width of your unit, and if it's not 6 inches, that is fine. You can still make it the right width, and all of that should work. Our width right now is 7 inches, actually, because we added the half-inch offset on each side for our material, so keep that in mind. But our height is not supposed to be 5.1 inches. It's actually 3 inches, because that is the height that we determined we wanted. Cool. So we have that. Wonderful. Now, what's next? We will build the mortises, or we will make the mortises for the sides. And I like to keep things kind of aligned the way that they are right now, because they make my life a lot easier down the road. The next thing that we need is deselect what you had here, and we're going to use another guideline because we moved our guidelines from earlier already. We move that down here, and then you can use another guideline. Really, seriously, make use of the guidelines. I try to avoid them most of the time when I play with this, but they make your life a lot easier for the next things. For example, we're currently on the edge of this side. Great. Where do I want my mortises to live? I don't want to take up too much space, but I also don't want to take up too little space that they're potentially break through the material, because the fiberboard that I have is very brittle when it gets thin, so I can't go super thin. How about half an inch? Half an inch sounds nice, but because we're fancy, let's just do 0.4 inches. Why not? Let's see where this goes. It puts the line right there. Is that too high up? Yes, I think that line is too high up. So we're just going to do another one, and I'm actually going to go to 1/4 inch, so 0.25. Is that better? Yeah, I like that one better. Cool. So now we have guidelines that run to the edge of our tenons right here, and that run to the edge of where we want to place something. And now this thing that we put away earlier comes in very handy. Click on it again to move it, left control, move it over, and then select the little corner icon here and put one right there. And, well, apparently I moved this again with left control, and that's fine. Move this one also to the same corner. So now we have two items, two holes, if you will, that are aligned exactly on the same alignment as this. So when you put these together, technically the front and the back of all the pieces should be in the same place. Wonderful. Now what? Well, if you will try to build this, and I highly encourage you to test fit all of these with the bits that you're going to use, because I test fitted this with a Badger. IDC makes good bits, not affiliated or anything, but they make good bits. I used a Badger. It was tight. I used a SPI tool, both 1/8 inch end mills, and the SPI tool made it super loose. It wasn't even remotely the same. Both Badgers broke that I had, so I had to use another bit. The bit said 1/8, but it wasn't 1/8. It was a little bigger than that, which means all the joints were a little more loose than what I wanted them to be. So please make sure that you test it with the tools you are planning on using for this. Okay, that's important. Well, if you cut this right now, it wouldn't fit because these are exactly the same size, if you're lucky, which would mean they wouldn't fit because I can't get inside something that's the same size. The receiving end, the mortise, has to be a little bigger than the tenon. So what do we do now? Oh, it's pretty simple. You just talk to these two guys and say, hey, can you be a tiny bit bigger than what you are right now? And the answer to that is, yeah, no problem. How much bigger do you want to be? I found in my testing for my problem that if I make these about 0.1 inches bigger, they fit really well. Actually, I lie, because I want 0.01 inches, not 0.1 inches. That would have been too much. If I do this, they fit really well. So to just see what the offset actually is, it is almost nothing, but it's enough for the tools, for all the pieces to fit together. So this is what the offset that I want. And if you select both of them, the offset is applied to both of them at the same time. Control Z, because I would like to delete the original. I don't want to see that. So now we have these guys just a tiny bit bigger than the other guys, and that's important. Great. We're doing wonderful over here. What are we going to do now? Well, there are more things to do. Trust me. Sorry, I actually don't mean to say trust me all that much, but I really had a lot of time building this stuff, so I hope this helps someone down the road. What is the next thing? Well, we have this one effectively done. We don't have it fully done yet because you know what? If you look at most of these, they don't have a straight front. You can leave this with a straight front. There's nothing wrong with it. But let's put a little design on here, a little something that makes it a little more special for us. How are we going to do that? First, I would like to remove all the guidelines. So delete all guidelines. Great. You can also just hide them if you want to come back to them later, but I don't think I do. So that's the first thing. And then let's just pretend that this is the front and this is the back. And in the front, I would like just a slight angle of something. I don't quite know what I want yet, but I want a slight angle of something. So we're at 6.3 inches here. Let's go about 2 inches up somewhere here and run a line. Run a line, whatever angle you want. You can make this scientific or you can just make it freehand like I'm doing right now. And at that point we will say, yep, cut it here. So put a little angle there. That looks good. I think I'm okay with the sharp angle here because when we put the front piece in, it will have to align with this. So rounding this is something you would have to do later on when everything's put together. But we can use the fillet tool with a normal fillet and some radius up here to just smooth this out just a little bit because you will end up touching this a lot and you don't want to cut yourself because dainty hands. So that should be good. Great. Now let's build the front. The front is next. The way that all of this goes together is effectively, well, these will fit into there, which means we need a guideline again because it's helpful, trust me. And if you don't get it aligned right away, just move left and right a little bit. So these guys will get aligned with this. They will push straight in, and that's our 1/2 inch selection. And then the top of the bottom is going to be where this guideline is going to run. So The space that we actually have inside the then container is just this, everything that's above the dashed line. So when we want to build our front, we have to recognize that. So what we're going to do is just build something that goes from there to there, which is a height of 1.2865 inches. Doesn't matter what the height is, you just have to make sure that you have the right one. And then we want a certain width. Can you guess what width this is going to be? It's not a Jeopardy question. It's not supposed to be difficult. The width is going to be what we determined earlier. You remember we made a plan. It's a 3-inch wide item, and this one is supposed to go in the front here. And we know that the width of this guy is about 3 inches. So we're going to tell it your width is going to be 3 inches. If this is hard to follow, and trust me, I get it, we will move these items around later to make it a little bit more sense. But for right now, leave them right here so we can actually get a couple things done. Because we're not quite done yet. We need the next mortise here. You have some choices. You definitely have some choices. We can use the same mortise that we already have over here. We can use the mortise that already has the offset, which in this case, I think I'm just going to use the offset. You do have to keep track of what you're doing, why you're doing it. Actually, this is the mortise. We need the tenon. So we're going to go down here. You see that I'm confusing myself, right? Good. We're going to move this one over with just control move, left control move, and then I'm going to use 0, 45-degree switch, 0, another 45-degree switch to move it over here. Then I'm going to select the item from the center. That's important. I'm going to align it with this, and it will snap to the center once you get to it. Right now, this tenon is in the center of this block. That's exactly what we wanted. Guess what? We need the same thing on the other side. So we're just going to grab this in the middle, move it all the way over here, and now we have two tenons looking exactly in the center of each other. To make our life a little easier, it's probably helpful if we remove the items that we have over here. If you had that problem from earlier, you remember how to fix that, right, with the nodes. But we didn't have one in this case. And when we click on this one, that looks like one unit. Beautiful. Love it. So let's add the receiving end, the mortises over here. I don't mind using the ones that we already enlarged because this should be just fine. Double click on it to be able to move it. Left control, move it over. Then 0, 0 to align it with what we have. And then you can do this trick again. It's not centered, now it's centered. You can see that's effectively exactly in the middle of whatever you want to do there. That's what we want. Let's place it, release it. And then I'm going to move it with my left Alt key so it stays in the X direction. And I'm just going to move it over here until I find a thickness that I'm okay with. I'm okay with this thickness. I don't know what thickness it is. It may be the same as this one. It looks pretty close to 1/4 inch, but it may not be. It doesn't matter what it is. It just matters that you have it aligned in such a way that this one can actually go there and get received by the item that you want to move. Cool. With that in mind, we can just say you have done your part, and now for easier alignment and understanding how our shapes are going to move around later, I'm just going to put it in the place where it's actually going to go, which is the front of this item. As you can see, it is the same thickness of what we have here, and I'm just going to use left shift and arrow keys to move it out of the way a little bit. This is just there so I can see that those pieces are not together. Cool, we have a front now. Guess what? The back is effectively the same thing. So let's go over it a little faster. We're going to have a rectangle over here. The height is exactly going to be from the guideline to what we have here. The width is going to be the 3 inches that we have determined earlier. And then I'm going to use my, there we go, left shift and arrow keys to move it out of the way. Then we will need some tenon to go in the front and back of this item. So I have this one, left control, move this all over, 0, 0. Select the middle of this guy and go to the middle of the rectangle that we built. It will snap to it, and then we're going to move the other one over here as well. Don't forget the left control. Everything is now nice and connected. There you go. Cut off the middle pieces. If it fights you, and it is fighting me right now, that's fine. If it wants to fight you, we'll just play the same game that we did earlier. Remove that one and remove this one in node edit mode, and we're going to click on these guys. Done. Very simple, right? The only thing we need now is a receiving end, the mortise. So double click on this one, left control, move it over, center it on this item, and then just move it to wherever you want to move it with left alt so it stays in the same alignment. This feels like it's far enough out. It really doesn't matter where it is. It's just how much do you want to give up on the space that you have inside the box. And now you have your mortise. Cool. We're almost done. Trust. I was going to say the thing that I didn't want to say. We're going to move 9, 9 to move it over here. And then we're going to click on it so we can actually move the center part of it. We're going to align it with our item that we already have. Now I'm just going to use shift left arrow to move it over. Wonderful. We're almost done, right? Almost. Not quite. This is French cleat country. This is where we want to have French cleats in. You have to know what angle you used for your French cleats and what thickness of material you had. I know that I have 3/4 inch thick material and I have a 45-degree angle. What I'm going to do here is going to build a square that is 3/4 inch wide and 1.5 inches tall. The 1.5 inches is very important because of the next thing that I do, because I need a second triangle that halves the first triangle, like this. Then I need a line, and this line is going to give me my French cleat alignment. It's just going to go from there to there. That's how a French cleat looks. You may disagree. Let me make it easier. You take this line out, and this line out. And then you take this line out. Now you can hang this on the French cleats that you have somewhere in your system. If this is just 1/2 inch wide, make it half an inch wide, and it's still just a 45-degree angle you get if you have 2 even sides. Pythagorean theorem. Pythagorean theorem. It's easy in German. So yeah, you just align this and you just need a 45-degree angle. If you have a different angle, do your math and figure out what your dimensions are. But you can do everything with a square and just cut that square in half. That should give you your French cleat. So we have that guy now. Are we done yet, Giant Woodworker? No, we are not quite done yet, because now you may find yourself test fitting this, and I would highly recommend you test fit this piece and one of the smaller pieces, just to make sure that things come together. And you may find that the angle is wrong. Good, fix it now. You may find that the thickness is wrong. Good, fix it now. You may find that the tenon fits great into the mortise, but there is a 1/8 inch-esque gap somewhere, and you don't like it. Yeah, I was there. You know what the problem is? These edges are square. These corners, because we are cutting effectively in 2 dimensions, not in 3 dimensions, these corners will have the radius or half of the radius of your cutting tool. So if you have a 1/8 inch mill, you will have a 1/16 inch round edge sitting there, which means your tenon cannot make it all the way to the edge. It will actually be blocked by something that has a tiny little circle. I'm exaggerating here, but it has a tiny little circle sitting right here, and you just can't make it to the edge because something is there. So you have to offset this with something. Don't worry, VCarve has a tool for that, and it's all out of magic. Here, this is all you have to do. Go to your fillet tool. In the fillet tool, you have options. Normal fillet, we already did that earlier for this roundover, and you can use it wherever you want. Then we have a dog bone, a T-bone, and a plasma drag knife fillet. We only care about the dog bone or the T-bone. You can pick whichever one you want. They're almost the same thing, because all they do is extend the edges just enough to be able to fit in what you want. What is a dog bone? You click on a dog bone. You currently have a fillet radius of 1 inch, which is quite extreme. I don't even know if the tool lets me do that. Looks like it doesn't like this one as well. If I click on this, will you? Nope, there's something wrong with my toolpath. Yeah, this guy hung around earlier too. Just the easiest one is just to remove those, and now we have one closed vector here because, nope, there's still one over here because we made two pieces of rectangles, and I think that is what is biting us here. There may be a node here or something else. I don't quite know what it is, but let's go to select that node mode and just remove this extra piece right here. I think now, yeah, that node is gone, which is perfect, which is exactly what we wanted. You will have to be able to diagnose what the problems are when those things arise. Sorry, but that is just how this works. And now this should be able to be treated as one vector, and we should be able to do our fillet piece. So we go in here again, and why are you fighting me? Do you have a problem? Do you have a problem? Do you have a problem? I'm not 100% sure what it wants right now. Let's see here. This one I can do, our normal round over, so the dog bone fillet should also work, but maybe it's just still a little too big. Let's go 0.125, that is 1/8. Yes, 1/8 will actually let me do the fillet. It's possible that our width up here wasn't allowing for a fillet of that size. But for a dog bone fillet, we can put a fillet in like this. A T-bone fillet, you go either to the edge on the north side or on the east side and click on it, and we'll just go out that way. Doesn't matter which one you pick, both of them will extend the corner just enough for you to be able to fit whatever you have, and you will just be able to see this on the outside. If you have a 1/8 bit and you do half of that radius, it's honestly not going to be that big. You may be barely able to tell that it's there, but these are tools that you can use for all sizes of your bits. I personally like the dog bone for this implementation a little better, and if you don't know how to divide 0.125 or 1/8 by 2, VCarve does it for you. So I'm just going to say divide by 2, then I click equal on my numpad, and that is the number. Cool. Click that. Click that, click that, click that. It would be really nice if VCarve at some point supports parametric solutions, but we don't have that just yet. So what we're going to have to do is go through and do this to all the mortises. And then you can't forget this. If you fit this in, and now you can see that the corner here fits right into there, there's an alternative. You can also round over all the edges and all the tenons, and then you can fit them as well. That is a different way. But if you want to do everything on the CNC, this is how I would do it. If you now push them in, guess what? There's still a rounded edge here because of the same reason for the tool, and that rounded edge just means it cannot seat all the way like edge to edge. It will not fit. So if you want everything to fit, you also have to put some fillets. Same radius if you use the same tool on the inside of all of your tenons. Looks like this. And we're zoomed in quite a bit. If you run this later on the CNC, you will probably barely able to see those show up anywhere. So that's where we are. There's one tricky fillet right here. The French Cleat has the same problem. This is going to be a rounded edge, and if you don't give it a fillet, it will always kind of just sit on whatever this rounded edge is and not actually seat all the way onto your French Cleat. So I highly recommend doing a little fillet there as well. May not look as attractive, but this will sit on the wall anyway, so you shouldn't have to worry about it. But now we are almost done. All we have to do now is, you can make a couple groups if you want, but right now I really just want to duplicate this so I have it on the other side, because this is one side and this is the other side. So we're just going to use our mirror selected item. We're going to mirror to the bottom just so it looks the way that we want to put it all together later, and move this down here. And this is the box that we can build. At this point, we're done with our tenon that we had earlier. That looks good. And this is really all the parts that you need. Cool. Before you go wild and cut as many of these as you possibly can, make sure it fits. Make your test fits with the boxes. If the boxes are not right, you have to readjust them to whatever the correct size is. Once you're happy with the sizes, print a full box and make sure that that all fits together. It's just scrap pieces, hopefully, at that point. And once you're happy with that, and only then, you can make your whole wall French Cleat toolbox containers. And this is your friend, the nesting option. Nesting option is wonderful. I just discovered it. And it does everything that I needed to do, and I'm actually pretty excited about it. So how does it work? There's a tool diameter. Well, I'm using a 1/8 inch end mill, so 0.125. Clearance. How much space do you want in between pieces? And I'm just going to do double my tool diameter. That's what I play with. Gap. This is literally the border gap. If you want to put in screws or holders or other things, you want a little bit of room, give yourself a gap. especially on a bigger sheet. This sheet is 48 by 48 because I can fit that. If you can fit bigger or smaller, just adjust it to that. The other parts kind of just work the way that they're described here. If you can fit something on the inside, do that. If you want to mirror some parts to find the best fit, then you can do that. A rotation step angle. I found that if I give it 1 degree, it actually wastes a lot more space. 45 and 90 degrees have worked better for me. Your mileage may vary, so play with that. And then you can say down here, how many number of copies do you want? Well, how about 25? And it will write a little number in here that will tell you exactly how many of those units it's trying to make. And if you're happy with everything, you can say preview. Well, it didn't fit on one sheet. And you can see there's a little bit of stuff wasted here. So you can play with those settings, but it definitely doesn't fit on one sheet. So Control-Z is your friend. And so 25, how about we try 18? Apply that. Preview. Hey, they all fit on here. And I think there's a little bit of extra white space. So Control-Z again. And let's say 19. Apply. That 19 is in there. Preview. Cool. I can fit 19 of these on one sheet. And you can cut it out. And as you can see, there's a little bit of room in between. You can also manually align all of this, but that's all up to you. We're pretty much done planning this. So if you're happy with how everything is lined up, and I didn't click the button, so apologies about that. I'll preview. Okay, now we're good. You're going to go over here. You're going to select everything that you want to cut, like you normally would. So now we're just going to do it in our toolpaths. I like the profile toolpaths. You can hog out the insides, but it's up to you. It will just take a lot longer. So I'm just going to do a profile toolpath. You see all the green dots. Those are the starting points. You select your starting depth and your cut depth. Cut depth obviously is just your material thickness, whatever that is, plus a tiny bit to not leave the onion skin. That's what you want to leave. Usually, if my material is 0.5, 0.02, 0.03 is just about as much as I need. You select whatever end mill you want. It really doesn't matter what you want to select here. Data out of date. No, go away. I don't want to update it right now. But let's say I'm using... Oh, wow. This one wasn't updated for a while. It doesn't matter what I use. You just set up whatever you want. You edit your passes like you normally would. You can add tabs. Obviously, this is a lot of pieces, so adding more tabs is going to take more time, and you have to clean it up later. And you should always add your ramps, then calculate your pieces, and just preview all your toolpaths, make sure that everything is working out. And in this case, our material is still set to 18 inches and not to 0.5. So now we're making 0.5. The rest is still the same. Yep, you want us to recalculate all toolpaths. That means we're going to cut through the material. Let's look at another preview. Reset preview, preview all toolpaths, and now we're actually going to cut through. This one looks like it doesn't have a lot of extra around it. Maybe that's good, maybe that's bad. But this is all completely up to you how you want to set these up. The other thing that you may have noticed is that we're actually cutting with a 1/4 end mill, and it's capable of doing that, but it's a little tight. So if you want to cut with a 1/4 end mill, and you know that already, you would set that up in your nesting. For right now, just switch it to a 1/8 inch end mill, recalculate this. I know we're going to cut through this. Wonderful. Reset the preview, and then preview all toolpaths. And now there's a little bit more wiggle room in between all the pieces, so you shouldn't run into any issues with that. Again, if you want to add tabs, go ahead. If you don't want to add tabs, it may be okay too. I mean, this is a shop project, so as long as you're safe, you may lose 1 or 2 pieces, but maybe you're okay at the end. But once you're done with this, we can actually go to cutting. So here we are at the shop. So this is the 48 by 48 sheet on the alt mill. I choose to do 4 screws, 1 in each corner. I regretted it later just a little bit, but generally it's okay for the bigger pieces. When I started, I didn't like how it wanted to take 3 passes, so I recalculated everything, tried 2 passes. I didn't like the surface finish, went back to 3 passes. Just pick what you want. It's completely up to you. It's your project, and whatever you feel is safe is fine. The Badger is doing an amazing job at cutting this quickly. I am not affiliated, but I'm honestly very impressed with these compared to the other items. And look how small that thing is. One other bonus is it's not as loud as the other bits that I have. So Double bonus, nice and dirty here. Dust boot goes back on in just a second. But yeah, it just kind of churns through all of this, no problem at all, and much quicker than I would have expected. Once everything was done, I was able to sand it and actually get a couple pieces together. Some of the mortises had some onion skin left over, so I had to push that out with that all. Later, I realized I had a file to make that a little simpler. But I was pretty happy with how all of this came together. It wasn't super easy, but it kind of slid in. There was not a lot of wiggle room. Everything did fit together just fine. And here's the product really quick. Yep, nothing's wiggling there. That's all the pieces that I made. There are a couple more on the table, and these are the things that I'm replacing. Super happy with it. Try it out. If you have any questions, let me know. Bye.